Resistors have a resistance measured in ohms that slows down charge from flowing. For a resistor, Ohm's law is the most important thing to remember. The change in potential across a resistor equals the product of the current and the resistance. So if you have a 5 ohm resistor with a 10 volt battery, it'll have 2 amps of current going through it. In circuits with a bunch of resistors, we have to often reduce these to make an equivalent circuit that'll be easier to work with mathematically. In circuits, we usually have a bunch of resistors. However, we can often reduce these down to simpler circuits based on if the resistors are in series or in parallel. If the resistors are in series, that means they share the same current. Think of it like a pipe. The same amount of water goes through the pipes that don't branch apart. When they are in series, we can model the system more simply with an equivalent resistor that has resistance equal to the sum of all of the resistors in series. If resistors are in parallel, this means that they must have the same potential across them. In this case, we can simplify the circuit of parallel resistors by using this equation, where we go on to however many resistors we have. Now we may give you a complicated circuit diagram like this and ask you to tell us the equivalent resistance for the simplified circuit. For this, just keep in mind the definitions of series and parallel and work your way backwards down to one resistor.